Welcome to the second lab of the FPGA Vhdl lecture series. In this lab, we will learn about the when-else statement which was covered in the first lecture. So, the aim of today's lab is to implement when-else statement in Vhdl. So, like in the first lab, to achieve this, we first go to our software, that is the ISA design suite. We double click on it. This opens up our project navigator window. For the second lab, we use a new project. On doing so, we are welcomed by the same create new project window. Let us name this lab or project as when-else with the same restrictions as followed in the first lab. Then we click on next. We let the settings be as it is in the first lab, like the family is Spartan 3E, device XCS 100E, package CP132, synthesis tool ISIM, preferred language VHDL, etc. Then we click on the next button. Finally, we finish our project. On hitting the finish button, we get the same FPGA chip XCS 100E-5 CP132 here, and on top of it we have our project when-else. To our project, we must add a new source file. This source file will be a VHDL module to program our FPGA. The name of this source file can be same as the project name. Then we click on the next button after selecting the VHDL module on the left side. Then we click the next button again. Finally, we finish. On hitting the finish button, we are welcomed by the same screen, but now the entity name is changed to when-else, that is the name of the VHDL module that we have already specified. In today's lab, we will be using the when-else statement. So the example that we will cover is the same as in the lecture. There are three inputs, namely A, B and C to our system. We have two control signals, assign A and assign B. There is only one output, that is Z, coming out of our system. The output Z is assigned to A when the signal assign A goes to 1. The output Z is assigned to B when the signal assign B goes to 1. If both the signals assign A and assign B are low, then the output Z is assigned to C, that is the third input. So effectively, we have three inputs, A, B and C to our system. Assign A and assign B are also inputs to our system. We have only one output, that is Z, from our system. So our entity part, where we declare all the inputs and outputs, has total 6 parts: A, B, C, assign A, assign B and Z. So writing the entity, we follow the syntax by typing port, opening brackets, capital A, colon, in specifies that A is an input of the type standard logic. Same goes with B, same with C. Assign A is also an input of the type standard logic. Assign B also of the same type standard logic. Z is an output also of the type standard logic coming out of our system. This is it. So we avoid the semicolon on the last line of entity and put it outside the closing round bracket. This finishes our entity part. In the architecture part, after the keyword begin, we write our code. So the syntax for when else is first the output, which must be assigned to an input. In our case, Z, the output, is assigned to A. When the signal, the input signal, assign A is 1. Any binary state 1 or 0 is always enclosed in single quotes. The equal to sign is written as it is. The keyword when turns to blue, signifying that this is a keyword. Now we have written the code for Z assigns to A when assign A is 1. But what about the other cases? So we write else, which is also a keyword. We avoid writing Z assigns to again. The compiler or the synthesizer understands that Z is assigned to B when assign B is 1. Else, if both assign A and assign B are 0, we want our Z to be C, simply. So here our when else statement ends. Z is assigned to C when both assign A and assign B are 0. This ends our when else statement. So we end it as usual with a semicolon. Then there is the end behavioral written in the end. It is good practice to indent all the codes for better legibility. Indentation simply means leaving spaces at appropriate places. Now, since our code is finished, we go and synthesize our code by double-clicking on the synthesize button. If the synthesis results in a green tick over here, then that means the synthesis occurred properly and there were no errors in our code. So, as we can see a green tick here, our synthesis was proper. Now let us view the RTL schematic and the technology schematic by double-clicking on the View RTL and View Technology. This button is used to fit our schematic to our window. Here we can see the multiplexer which was created by the when else statement that we wrote. This ends our lab 2. In the next lab, we will learn a new statement using the Vhdl. There is also the concept of test bench to be learnt in VHDL for simulation purposes, which will be covered in the later lecture.